Good afternoon. I'm George Hepworth of Grover Park Consulting. I have built many Access relational database applications for clients and customers over the years. Today, I'm going to be telling you about a new way to leverage the power of those robust Access relational database applications you have created for your customers in a way that will allow you to extend some vital piece of that functionality into the mobile environment. I'm talking about phones, tablets, and the browser. Although I say a new way to do this, PowerApps have actually been around for quite a while. It's just that as Access developers, many of us have not paid that much attention to PowerApps. With PowerApps, we have the ability to extend some small part of the functionality of a fully robust relational database application built with Microsoft Access for the Windows environment. We can take that one piece of functionality and extend it so that it runs in a mobile device and empower our users to leave a fixed location and work on that particular function from virtually anywhere where they have the ability to connect. One of the limitations of PowerApps that held me back for a long time, and I think probably held back other Access developers, is the limitation on the number of records you can retrieve. By default, out of the box, PowerApps are configured to allow no more than 500 records to be loaded into the application. That's configurable up to 2,000. And for many smaller data situations, that's adequate. But for many of us working with thousands or even tens of thousands or even hundreds of thousands of records, that always seemed like a showstopper, and I think it held us back. We as developers recognize that we don't necessarily want to load 10,000 records or 50,000 records into a single form, but the ability to have those records available to us when we need them has been something that has put an impediment in front of us. I'm going to show you a way to get around that. I call it tricking PowerApps into loading 10,000 records in a gallery. For those of you who are familiar with PowerApps and have worked with them before, the technique I'm going to show you is familiar and one that I have seen several people incorporate into their solutions. However, I think for the purposes of Access developers, I want to take it from the point of view as saying we have this limitation, let's see how we can get around it. We'll do a workaround. I'll call it tricking PowerApps. I've already started my demo PowerApp in the Microsoft 365 environment. I'm editing PowerApp's Canvas application in tablet mode. This particular application has 4 screens. Again, just a quick background for Access developers. Screen is roughly the equivalent of a form in our environment. So we have 4 screens, 4 forms. The first is the startup screen, and that's the one we're looking at here. I also have an options screen, and I won't explain how I use that. In a later video, I'll go back and pick up that and explain how I use the options screen to set some default values for this PowerApps. You can see that I have particular color scheme here with the light blue and the white, and that's controlled by screen options. Within the PowerApps, I have 2 working screens. One loads a table directly from the record source. The other loads a collection. And in order to explain the collection, I'm going to actually start with the table version and show you that 500 record limitation in action. We'll play the application, and for those who are coming from the Access world, I will probably slip up and say run the application, because that's how we refer to it, but it's actually play the application in this environment. So I'm playing it now. I have two buttons that load items from a table. This source table is currently in SQL Azure, and it currently contains 9,414 records. Not quite 10,000, but close enough for our purposes. When I click the button, it takes me to this screen. What's happened here is that this gallery on the left, a gallery is a tool that displays a list of items pulled from a data source. This gallery on the left pulls in the first 500 records from the table. I said liar, liar, pants on fire in my little tooltip because I just showed you that there are actually well over 9,000 records. The PowerApps default limitation of 500 kicks in. That's all the records it retrieves. Even though there are thousands more, as far as this particular screen is concerned, 500 is it. The number of records in this gallery then matches. We've loaded all of the records up to 500, and we've taken that 500 records and loaded them into this gallery. This is based on an event scheduler. So we have, for example, a dinner meeting, an afternoon workshop, main session, and so on. These numbers here in red are the event IDs from the table. When I set up the demo table, I made sure that they were all consecutive so we can see the counts and they line up with what's actually there. In a real working table, you know there would be gaps because records get added and deleted and so on, and so we end up with gaps in our sequence. But for this demo, they're all there. So 500 records, and they're all loaded. We have the ability to sort. And you'll notice how it hesitated for a second there. That's because it hit, it's actually loading the records behind the scenes in 100 record chunks. So as I scroll down, you'll notice that it will get to a certain point and then it will hesitate and then it will load more. That's because it's hitting that 100 record mark. We have the ability to sort from newest to oldest. And that takes a couple of seconds. You can already see with only 500 records, response times are not that great. So we went from March of 2016 through July of 2016 to get the first 500 records. If you were trying to load the full 9,414, you can imagine just how unresponsive it would be here. And actually we're going to see that when we look at the collection. So that's the default situation with loading a table directly. I'm going to bail out of here, look at the code which actually launches this, actually populates this gallery. You'll notice that it's filtering on the full table event. And we have a conditional here that says if we have a search field designated, we're going to find the event that matches that date. Otherwise, we're going to bring in the entire table. Because it is unable to bring in more than 500 due to that limitation, it gets to 500 and quits. And then here's our sorting. So let's run it, play it again. And you can see the lag time as we are contending for resources on my computer as we're trying to play the application. I'll click it and be patient and wait. and it loads again. Okay, so now we're going to go to the other gallery. This one is based on a collection. A collection in PowerApps is an internal table-like structure. It's similar to a collection in VBA, but it's a collection based on some data source, which in most cases will be a table or a SharePoint list. And in this collection, we collect all of the records that we're going to work with in that current situation. So by default, a collection would have no more than 500 records because it would be able to get that many records from the table. However, I've set up my trick, and you can see that it loaded 9,414 records. All of a sudden, it went away and reloading the collection and reloading the gallery. What happened there is that the method I used to invoke this collection is the visible event of this particular screen. So whenever this screen becomes visible, it dumps all the records in the current collection, goes back to the data source, and rebuilds the collection with all the records. You can see that it got the first 4,959 fairly quickly. We're seeing them in this gallery, even though it's telling us that there are no records in that gallery yet. That's because this still has not updated from the prior view. Now it's caught up. So what's going to happen is it's going to start loading records into the collection in chunks based on this particular list that you see here. And I'll show you that, how I create that list in a second. But it's going to go from 49.59 to 54.55. And as soon as that collection is loaded up to that point, it will attempt to load those records into the gallery. And we're getting timeouts again because of the slowness. And I guess that gives me an opportunity to remind you that even though we can do this in a real life situation, we wouldn't want to do it this way. There are other ways to use that full collection that don't invoke this kind of problem by filtering. But for the purposes of this demonstration, I wanted to show you the entire process, collecting all of the records, populating them all into a gallery, and also as a secondary factor, illustrate just why we don't want to do that. It's the same principle we see in Access. Even though we've got that many records available, we're reluctant to load that many records into a single form at any given time. We'll filter it down to bring in one record that we're going to focus on and use. So it's chugging through my list here, and we're up to 6447, so we've got quite a ways to go. It loads the records into the collection, and then it puts the records into this gallery on the left. I'm going to pause the video, wait for it to catch up, and then come back. Okay, we're almost done. I brought you back. We're on the next to last iteration. It's loaded those records up to 8927, or it's in the process of loading those records up to 8927 into the collection, and then it's taking the records from the collection and putting them into this gallery. Excuse me. We have one more chunk to retrieve, and it's doing this in units of approximately 495. Even though the limit is 500, because I'm using slightly less than 10,000 records, and we're dividing those records into even chunks, the method that I use results in intervals of 495, slightly less than the total of 500 that we could retrieve. So one more iteration to finish loading the records into the gallery. And we can look at how we do this. I don't think I want to show you the sorting here or the filtering. Actually, maybe I will show you the filtering. As soon as we get control back, we're still loading them into the gallery. You can see across the top there's a little series of dots. Some people call them ants that run back and forth as you're loading records. So now I've got control back. I can filter this. And it responds quite quickly, because even though we've got 9,414 records in this collection and in the gallery, once they're in memory, we're working within the limitations of the browser, and we're no longer running against the limitations of the data retrieval process. So it responds fairly quickly here. However, if I remove my filter, this will take a while to update again. You can see it's stuck on 5 because it's refreshing the gallery from the collection, and that's going to take a few minutes. Okay, we gave it enough time to refresh the gallery, and we can go back and look at the code which does this for us. I'll stop playing the application, and I'm going to take, first we'll look at the visible event of the screen itself to see how the collections are created. When I say collections, I'm sort of foreshadowing the fact that there's more than one collection involved. This is the entire process. It runs when this screen becomes visible. If you go away from the screen and come back, this reruns itself on the visible event. The first step is we clear 2 helper collections. The recursion count is a little collection that has the number of times we need to go through our entire database, 500 records at a time, to get all of the records. As you can see, if we do a calculation, we come up with approximately 18.86 iterations or recursions to get all the records, and we round that up to 19. The recursion count collection helps us do that. The second collection is iteration spans, and iteration spans is the starting and ending event ID for each of our 19 recursions. Once I calculate this collection of iteration spans, then I can use that to pick the first record in a chunk and the last record in a chunk and bring those records in and remain under the 500 record limit. The final step is to clear the collection of events. This is the master event of all 9,414 events. And as you saw when I first made this screen visible, it showed 9,414 and then it showed 0. And that's because it hit this statement and cleared that collection. Our first step in rebuilding the collection is to find out which record is the first record. We do that by saying, let's look at all the event IDs in table event, sorted in ascending order, and pick the first one. That should give us the lowest or least or first event ID in that entire table. It's 1 by default here because, as I said earlier, I ensured that my table would have consecutive values. But it will always return the lowest event ID or primary key in your table. And we'll call that the first record. We do the same thing to get the last record. And that one is calculated in the same way, except we're sorting descending. So we get the largest or the most recent or the last event ID. So now we know the first ID and the last ID in that table, and we should be able to use that to calculate how many iterations we're going to have to go through to recursively collect all of those records in 500 record chunks. And that's the variable called iterations. And as I just showed you, we get that by subtracting the first ID from the last ID, and that gives us the maximum range. You know that if you have deleted records in a table, those records should be between the first and the last primary key value. And so this number may actually be larger than the number of records you actually have to retrieve. However, it should give us the largest span that would be required to bring all those records in. And by dividing that by 500, then we know how many times we have to iterate. We round up to 19. Excuse me, the next highest number, which is 19. We want to look for the last event ID. This tells us how many records we should, at a maximum, have to retrieve, and that's how we can come up with the 9,414. The first time I did this, my math was off. I subtracted the first event ID from the last event ID and got a number, but it was one less than the total number because I forgot to account for the fact that this one was being subtracted out. So I added one back, and now my max event count matches the actual number of records. Okay. The next step is to create another helper collection. This one I called event temp, and the only purpose for this one is to give my iterations something to tally against. We use clear collect instead of just collect because it dumps whatever's in there and refills it. Those of us who are Access developers are very familiar with the idea of tally tables and probably used them many times. But it's just a list of values, numerical values. In this particular table, I have 1 through 50. You could make it as large as you needed to account for all the records if you had a really, really big record set. It takes a field called tally count, sorts that field from smallest to largest, and puts that into a collection. And you can see that it generates one value for each of the records in my tally table. The next step is to take this collection, which has all these numbers in it, and we create another collection where the tally count, that's this value, is less than or equal to the number of iterations. So we have a starting number of 50, but we only need 19 of those. Because that's how many iterations we need to collect all the records in this particular table. So I'm going to use that to filter down this full count to only include the number of recursions that I actually need. Let's review how many we got. We selected the recursion count collection. We scroll down, we see that we have 19. The value is 1 through 19, and that's how many times this final step will run to bring in all of the records from the underlying table. the next step, we're using the Forall action to iterate over this collection, which is the count of the number of times we're going to have to recurse it. We're going to collect iteration spans. Iteration spans will consist of the first or the lowest record in each chunk of 500 and the last record in each chunk of 500 based on the number of iterations and the total number of records we have to bring in. So scroll up to the top. So the first time we recurse, first item will be 0, the last one is 495. That 495 is less than 500 because our total number of records is less than 10,000. If it were an even 10,000, that would also be an even for 500. The next item it picks up is 496 through 991, and that's our second pass through, and so on. How do we get there? We go through the recursion count. We count the number of rows that we've already gone through and add 1. This is our iteration for all. This will increment as we go through it. As we go through this recursion, and again to repeat, the for all is the way we recursively process each of the items in this collection. We're going to collect the value of the pass we're on, and that is the number of times we've gone through it. So that'll start with 1 and go through, increment by 1 as we pass through, and each successive recursion will increment that by 1. The values we get are the first and the last. Now, this mathematical formula generates the first item in that particular pass, and this one generates the last item in that particular pass. I won't try to explain the math itself. I will just talk through in words how it works to give you an idea of what we have to do. And those of you who are really good at math will figure it out. So we get the value, and that is going to be 1, 2, 3, 4, 5, and so on. Then we calculate the number of events, the maximum number of events, divide by that by the iterations, and that will give us the number of items in that chunk. We multiply that by the value. So the first time we get here, we have 495 times 1, and we subtract that same value back to get it back to 0. And that gives us the first item in the first pass, which is 0. Technically, we want 1, but it doesn't hurt to start with 0. We get the last item by doing the same basic calculation, finding out we need 495. We multiply it by the value, which is 1. So we take 0 to 495. Because we're doing the roundup, and because 495 is actually something like 495.287 or whatever that is in decimals, then we have to subtract the 1 to bring that rounded number back down to where we want it to be. So on the first pass, it will collect first item as 0, last item as 495. On the next iteration, value of the recursion count will be 2. Do the same calculation, multiply 495 times 2, that gives us 991 if I remember correctly. We subtract back this current iteration, which is 495, that takes us back to 496. And again, it's 496 because we're rounding up. The last item in that iteration, again, is the 495 times 2, 991, or 992, minus 1 to get us back to the next lowest number. And each time we pass through this recursive process, we get the first and the last event IDs in that chunk based on the total number of records and the chunk size, which is 500 in this case. Now we have a collection of iteration spans. And I just talked through this, and now you can see in black and white what that looks like. The value on the first pass of the first item is 0. The last item is 495. When we pass through it a second time, the first item now is 496. The last item is 991. We multiply our base value by 3, subtract it back, we get 992, 1487, and so on. Each time you iterate through this process, we get a new row in our collection representing the first and last event IDs, and these will be the event IDs for that particular chunk. And then the final step, we take this collection and we use it. We're going to iterate across it, and again it'll be 19 iterations. We're going to collect into the final master event collection all of the records from the underlying event table, 9,914. But we're going to filter it in this particular iteration where the event ID is greater than or equal to our first item and less than or equal to our last item. That will add one row at a time, 495 rows, into this collection events collection. And that allows us to bring through 495, 495, 495 at a time. We're honoring the 500 record limit. But by the time we get done, we have all of the records in that entire record set. And I double-clicked on this, and it shows me the records. And it's going to stall out here because it takes a long time to load that many records, and I won't dive into that right now. So that's how it works. I'm going to pause while we clean up a bit and get reset, and then I'll come back and wrap up. Okay, I believe that's enough for this session. I've shown you how you can actually trick PowerApps into loading thousands and thousands of records into a collection and then use that collection to populate a gallery. I've also illustrated, I think, fairly effectively why we really want to do that in the wild. My purpose here was twofold. First, to show you that it is possible and that we can actually incorporate PowerApps into our existing relational database applications, secure in the knowledge that this limitation imposed by PowerApps is not a deal breaker, to be blunt about it. And also to show you that even in this environment, or especially in this environment, it's really important to observe good data practices in the way we manage that data and bring it in and work with it in our day-to-day work. I hope you like what you've seen here today. If you have, I would appreciate it if you would subscribe to my channel, hit the like button, and come back soon. I will provide further information on this particular implementation and move on to other aspects of PowerApps that I think are very, very useful for most Access developers. Thanks.